Imagine asking a team to build a skyscraper without an architectural blueprint. What would happen? The project would suffer from miscommunication, wasted resources, and a structure that does not meet expectations. The same issues occur in software development when there is no software requirement specification, or SRS. The SRS is a detailed document that defines what needs to be built, how it should function, and the constraints that must be considered. A software requirement specification, or SRS, is a structured document that outlines all functional and non-functional requirements of a software project. It serves as a contract between clients, developers, testers, and stakeholders, ensuring that everyone involved in the project has a clear and shared understanding before development begins. A well-defined SRS eliminates confusion, minimizes the need for rework, and ensures that the final product meets the client's expectations while staying within budget and deadlines. To better understand the importance of an SRS, let us explore its key components using an example of a food delivery application. The introduction section provides a high-level overview of the software project. It includes project purpose. What problem does the software solve? Target users. Who will use the system? For example, customers, restaurant owners, delivery personnel, and administrators. Scope. What features and functionalities will be included? This food delivery application aims to connect users with nearby restaurants, allowing them to browse menus, place orders, and have food delivered to their doorstep. The primary users of the system will be customers looking to order food, restaurant owners managing their menus, and delivery personnel handling deliveries. Functional requirements describe the specific actions the system must be able to perform. In a food delivery app, functional requirements may include: users must be able to browse nearby restaurants based on their location. The system must allow users to add items to a cart and complete orders using multiple payment options. The application must send real-time notifications when an order is placed, prepared, and delivered. Non-functional requirements, or NFRs, define how the system should perform. They focus on the quality attributes of the software, such as performance, security, and user experience. Performance. The system must respond within 2 seconds for any user action. Security. The application must support multi-factor authentication and encrypt all sensitive user data. Scalability. The system must be able to handle at least 1 million concurrent users without performance issues. User experience, or UX. The application interface must be intuitive, responsive, and visually appealing. System requirements detail the hardware and software specifications needed for the project. This section defines the technology stack and other technical dependencies required. For example, the front end could use React.js or Angular for the user interface, while the back end might be managed by Node.js or Django. The database could be PostgreSQL or MongoDB for storing user and order information. Hosting could be done on AWS, Azure, or Google Cloud for cloud infrastructure. For instance, a cloud-based food delivery application may require AWS EC2 instances, a PostgreSQL database, and a microservices-based back-end architecture. Compliance and constraints outline any regulatory compliance requirements and project limitations. For example, the system must comply with GDPR, the General Data Protection Regulation, to protect user data privacy. Project deadlines might require the first version to be delivered within 6 months. Budget constraints could mean the project must stay within a development budget of $500,000. If the app handles financial transactions, it must also comply with PCI DSS, the payment card industry data security standard. Why an SRS is essential. Without an SRS, teams will misinterpret requirements, leading to frequent miscommunication. There will be constant revisions, delays, and budget overruns. The final product may not meet client expectations. With an SRS, developers and testers will have clear, documented expectations. The software will require minimal rework, reducing overall development costs. The project will be executed smoothly, ensuring a successful product launch. Common mistakes in writing an SRS. Let's compare a poorly written SRS for a food delivery app with a well-written version. Poorly written SRS example. Functional requirement. The app should allow users to order food. Non-functional requirement. The app should work fast. System requirement. The app should run on a server. What's wrong with the poorly written SRS? The functional requirement is too vague. It does not specify how users will order food or which features must be included. The non-functional requirement is ambiguous. What does fast mean? A precise response time must be defined. The system requirement lacks detail. It does not specify which server technology will be used. Well-written SRS example. Functional requirement. The application must allow users to browse nearby restaurants, select food items, add them to a cart and complete the checkout process using credit cards, PayPal, or digital wallets. Non-functional requirement. The system must respond to user actions within 2 seconds and handle at least 1 million concurrent users without performance degradation. System requirement. The application will be hosted on AWS EC2 instances using a microservices architecture with a PostgreSQL database for storing order information. How the well-written SRS fixes these issues. It provides clear, detailed functional requirements so developers understand exactly what needs to be built. It defines measurable performance standards to ensure the app functions efficiently. It specifies the technology stack so the infrastructure team can set up the correct environment. Best practices for writing an SRS: use clear, unambiguous language. Avoid vague terms like should be fast or must be secure. Instead, specify exact performance and security metrics. Be detailed but concise. Include all necessary information without adding excessive complexity. Use diagrams and flowcharts. Visual representations can help explain complex system architectures and user flows. Review and validate with stakeholders. Ensure that business teams, developers, and testers all understand the requirements before development begins. A well-written SRS is the foundation of any successful software project. It ensures that projects are delivered on time, within budget, and meet the client's expectations. Have you worked with an SRS before? Share your experience in the comments. Like and subscribe for more tech insights.